Today we're going to talk about dividing with decimals. Again, this is something that you have done in previous classes before, but we're going to talk about, well, why does it work that way? So let's take a look at this first example. Victor is trying to do a division problem with decimals, but he doesn't remember the standard algorithm. An algorithm is, a set of steps that you have to follow in order to do something for division of decimals. He rewrote the problem as a fraction, and he knew he should multiply by a giant 1, but then he got stuck. Help him by finding a giant 1 that will change the problem into one that has no decimals. And I gave you a hint. Think of the place value of a number that is 1 past the decimal. Never closed the parentheses, though. That was bad on my part. Then simplify the problem. So, 1 place behind the decimal is what place value? What is it? The tenths place. So I can multiply by 10 over 10. And when I do that, I get 34 over 2, which is 17. So let's use the same procedure here. 0.84 divided by 0.21 is equal to 0.84 over 0.21. What could I multiply this by to get rid of the decimals? Just by 100? There we go, 100 over 100. Because we're wanting to multiply by 1 so that we don't change its value. So that's 84 over 21, which is 4. So after looking at your work, Chad noticed that the answer to the first problem was the same as 34 divided by 2, and that the answer to the second problem was the same as 84 divided by 21. That's brilliant, he thinks. That means that 0.09 divided by 0.2 is the same as 9 divided by 2. What do you think? Will Chad's idea work? No. So, if we're doing 0.09 divided by 0.2, that's the same as 0.09 over 0.2. To get rid of all the decimals, what would I need to multiply by, top and bottom? Yeah, got to multiply by 100 over 100. So that's going to be 9 over 20, not 9 over 2. Very different answers. If I do this with long division, it would be 20 divided into 9. 20 won't go into 9. So I'll add a decimal and start adding zeros after it. 20 goes into 9 4 times. Or 20 goes into 90 4 times. That's 80, leaving 10. We'll add another 0 and bring it down. 20 goes into 100 5 times. This is 0.45, not 4.5. Okay, any questions about that? All right, so what's the standard algorithm? In case you've forgotten, When you're dividing by a decimal number, one way to proceed is to count how many digits the decimal must move to the right in the divisor, that's what you're dividing by, so that it becomes an integer, that is a whole number. Move the decimal point in the dividend the same direction, the same number of digits. So for example, if you have 8.3 divided by 4.07, we're dividing by 4.07, so we need to move the decimal 2 places. We need to move the decimal 2 places in the dividend as well, what you're dividing into. It's the same thing as multiplying both numbers by 100. You end up with 830 divided by 407 if you do this with the giant 1 property. All right. So, with these down here, there's 3 of them. Do at least one of them by getting rid of the decimals by multiplying by a giant 1 of some sort, and do at least one of them the long division way by moving the decimals. And then whichever one you haven't done yet at that point, you're welcome to do with whichever method you prefer. I'll give you a little bit of time to do that. For those of you who finished, feel free to check with someone near you to make sure you guys agree on your answers. All right, I know that not everyone is quite completely done, but let's go through these. I'll do each of them both ways. So here, if I'm getting rid of the decimals, I can multiply numerator and denominator by 100. That would give me 250 over 25, which is easily done. That's 10. If you do it by the standard algorithm, that's 0.25 divided into 2.5. We move the decimal 2 places to the right. So we have to move this decimal 2 places to the right also. 25 goes into 25 once. 25 goes into 0 0 times. So we get 10 that way also. Any questions about either of those methods for this one? For this one, I think especially if you're doing it in your head, it's a lot faster to do it the first way. And for the second one, again, I need to multiply by 100 over 100 if I'm going to get rid of the decimals. So that's going to be negative 1,120 over 7. And that one is probably big enough to where, because I'm going to have to do this now, I probably would have used the standard algorithm to start with. That goes once. Subtracting the 7, we get 42. That goes 6 times. Subtract the 42, we get 0. And then 0 again. This is negative 160. And for this one, I think it's probably faster to have done the standard algorithm because you had to end up doing long division anyway. We have to move the decimal 2 places to the right, so we've got to add on an extra 0 to our dividend. And now it's exactly the division that we did down here. 7 goes into 11 once. Subtracting, we get 4, bring down the 2. 7 goes into 42 6 times. Subtracting, we get 0, bring down the last 0. 7 goes into 0 0 times, so we get negative 160 that way also. The last one, we only need to multiply by 10 over 10. It's 5,910 divided by 3. Let's see if I can do that in my head. 5 into 3 goes once with 2 left over. So that'll be 29. 3 into 29 goes 9 times. That's 27. From 29 leaves 2. 2 goes into 20. 3 goes into 21 7 times. So this is 1,970. Real quick, do you guys know the trick for divisibility by 3? How to know if a number is divisible by 3 just by looking at it? You know that one? Yeah. I got all the numbers added together. A little louder for me. Is a multiple of? Yeah, a multiple of 3. If you add the 5 plus the 9 plus the 1, that's 15. That's divisible by 3, so is the original number. It's handy sometimes to know if something's easily divisible by 3 or not. This one, it's about 6 of one, half a dozen of the other as to which one is faster. Got to move the decimal one place. 3 goes into 5 once. Subtracting, we get 2, bring down the 9. 3 goes into 29 9 times, and that's 27. Subtracting, we get 2, bring down the 1. 3 into 21 is 7. We get 0, bring down the 0. That's going to go in 0 times. We get 1,970 either way. And you're welcome to use either of those. Any questions about that? All right.